Okay, so we're live. Thanks everybody for our April Tech Talk. We're excited today. We've got a guest we've never had before. We've got a topic we've never spoken about before. We've got lots of people waiting on the line. So I think, as usual, I'll just sort of explain how to ask your questions, introduce the topic, introduce our guest, and we'll probably just get right into it. So as you guys are watching the stream, if you've never been here before, use hashtag Layer7Live if you want to tweet questions at Irakli. You can also email them if they're a little bit more complicated or you can't actually stick around to wait. Email is techtalk@layer7.com.
Right.
So, and also if you're in the player watching the video, just to the right, there's the chat window, so you can live chat your questions to Irakli. So, as people join, I'm just going to introduce Irakli. He's a recent member to the API Academy, and we're really excited to have him talking about linked APIs and how to avoid data silos. And I think I'll let Irakli introduce himself and then sort of frame the discussion by introducing the topic. And we're also going to give away one of these lovely API shirts that Jose here designed. We've got a blue one. We've got what color is this? Wine?
Technically, I think they call it cranberry.
Cranberry, okay. Got APIs. So whoever asks the best question throughout the discussion today, we'll just go offline and get your mailing address and we'll mail you off a shirt, maybe even both. So Irakli, how are you? Thanks for joining us today,
Steve.
all the way from Philadelphia?
Washington, D.C. actually.
Oh, Washington, D.C. Oh, okay. Nice.
Hey, Steve. Hey, Jose. How are you doing?
Doing well.
We're good?
So we're having a beautiful sunny day in Washington, D.C. today. So thanks everybody for joining. Hopefully you're also enjoying the nice weather. And I know that on the East Coast, at least, it's lunchtime. So I appreciate people taking their time today in the middle of the day to listen to and participate in the conversation about linked APIs. So I would like to start by explaining, before we get to what linked APIs are, I would like to start explaining why this is important and what is the context in which you might want to think about linked APIs. So the context in which linked APIs are important and in which we have run into the need for linked APIs is the context of the changing meaning of big data, right? So big data is a very, very hot topic. Part of the reason I believe that big data is a hot topic is because we have so many more sensors these days, right? Compared to what we had 10 years ago. All kinds of devices, all kinds of context and platforms are collecting a lot of information. And mostly it's coming as raw data. And there's a huge need to connect the dots, so to say, right? To make sense of this enormous amount of the data. And what I see in our work at the API Academy and elsewhere is that the meaning of the big data and the challenges of the big data is evolving, right? So here's the Wikipedia definition of big data. Big data is the term for a collection of data sets so large and complex that it becomes difficult to process using on-hand database management tools or traditional data processing applications. So that's how Wikipedia defines big data, right? And a lot of times in previous years, we have concentrated on the size part of big data, the fact that it's often described as petabytes of data or Google size data or Facebook scale data or web scale data. And the thing is that in the recent years, we have actually gotten pretty good at managing the size of data. We have a lot of really powerful parallel processing frameworks and tooling now, including Hadoop and some others, even in open source. So we have grown a lot in the sense of how much we can manage the large size of the big data. But the part that is still largely untamed, and I think will become more important in big data, is the complexity of the big data. Specifically, is not the case anymore that the data sets we have to work on is all local data, right? A lot of times we have to manage the data sets where the pieces of the data set are owned and maintained by different organizations. We need to connect data sets across organizational boundaries. And this is a continued challenge because most API examples we have today, the most well-known APIs, the APIs that a lot of us are holding as the examples of how to build scalable APIs, they're actually completely siloed, right? So it's strange enough that APIs have been a huge growth engine for the web in the last several years, but APIs in some sense have also compromised web, because a lot of APIs have created this walled garden silos on the web that is actually not very organic and not very natural to the web. So what I mean by that is if we take some of the most prominent examples of large APIs, right? Very remarkable APIs. So I'm going to single out Twitter API, which I'm a big fan of Twitter, and I think that they are doing an amazing job of deploying such highly scalable API. But if we look at it from the point of view of a distributed system, right? Twitter API is an extremely powerful API. It's an extremely scalable API, but it's also a complete data silo in the sense that I can run all kinds of queries. I can run RESTful queries against it. I can use their streaming API, but the data items in the API that I can access, they're all local to Twitter, right? I can only query the tweets that were originated in the Twitter's database. So it's all local data. It's not like I can connect or query the tweets that were originated somewhere else. And it sounds very natural for us because most APIs are built that way these days. But at the same time, if we compare it to the rest of the World Wide Web, it's very unnatural, right? World Wide Web is a very distributed publishing platform. For me to connect my piece of content to a piece of content on New York Times or Huffington Post, I do not have to send them my content so that they can store it in their own database. Likewise, for Google to search things, I don't have to actually send them structured data item that they will be storing in their database. They're in the business of managing an index, so their service is more of an index. And I believe that APIs, especially the APIs that are trying to tackle the challenges of big data, the APIs that are trying to index the data sets that go across the organizational boundaries, similarly have to be indexes, first and foremost. And they should not pretend that they are authoritative data sources of the data sets that they are not. And in a lot of cases, that is what is happening right now. And unfortunately, in a lot of cases, APIs are very significant silos for the data sets that you can query in them. And I think it has a lot to do. There's a very interesting article published by Microsoft Press by a fellow called Pat Halland. It's called Data on the Inside versus Data on the Outside. He published it when he was working back at Microsoft. Pat is a very interesting person. He worked on Azure for Microsoft. He also worked on AWS for Amazon. And I believe he works on Salesforce cloud deployment right now. So definitely a person that really understands cloud computing, definitely a person that really gets big data management. And he discusses how a lot of things that we're used to doing when data is local, which he calls data on the inside, are actually do not actually hold up when we're dealing with the data on the outside, when we're dealing with the data at the distance, right? There's some very specific laws of physics actually that come into the play, because when you're trying to connect things at very large distance at web scale, right? There are some very physical limitations. Given the speed of light and the speed at which the information can propagate, we cannot assume that when I make a request on the east coast of the United States, and if I'm connected to something in Japan or Australia, that things are going to be instantaneous. They can rely on things of like that things, all the things happen at the same time. The notion of time becomes very relative. So all those things come into the play. And in that sense, I believe that the big data challenges of the future will be solved at the intersection of APIs with web and hypermedia architecture. Web and hypermedia architecture is the biggest, most reliable architecture that we have, that we know that solves highly distributed system problems. So it will be intersection of APIs with web hypermedia architecture, linked data, and what we currently call big data tooling. And that is exactly what I call linked APIs. And I call it linked APIs mostly to differentiate it from the current siloed state of most web APIs.
Great. You know, Irakli, I'm just going to go back a little bit because I noticed quite a few people joined since we gave the introduction. It happened, so there's several more people on the stream right now. So I just wanted to, thank you guys for coming and welcome everybody. This is Irakli from our API Academy, which you can check out at apiacademy.co. Basically, the API Academy is a team of API designers and architects to help people develop good API design best practices and help them design good APIs. And Irakli is the newest member. So I just wanted to mention that in case you missed who our guest is today. Also, feel free to chat your questions right through the chat window. You can use hashtag Layer7Live, and like I always say, you can email them in to techtalk@layer7.com if it's a longer, more complicated question, or you just simply don't have the time to sit at your desk for the next half an hour and wait. But yeah, we welcome everybody, and thanks, Irakli. Actually, would you mind introducing yourself a little bit?
Sure. So my name is Irakli Nadarishvili. I'm a new addition to the API Academy. It's CA Technologies. I work on the problems of big data and distributed systems and highly scalable systems, specifically using API-first architecture to tackle some of those problems. Before CA Technologies, I was running the technology team at NPR, this National Public Radio, specifically the digital media team there, which deals with the APIs, the web properties of NPR, and also mobile applications.
Great. I also wanted to say, if we've got Arif Mustafa on the line, or on the stream, we've got your question, and we'll probably get to it after a few minutes. Hopefully you're here, and thanks very much for submitting that. Great question. So I think, Irakli, we'll just kind of get right into it. If you've finished introducing the topic, I'll just dive right into the questions. What are the differences and similarities between linked APIs and linked data?
So that's a great question, Steve. And for the last several years, we've been hearing a lot about linked data, right? Linked data is one of those concepts that was championed by Tim Berners-Lee himself,
right?
And I believe he even dubbed it as like Web 3.0, the future of the web. A lot of work has gone in linked data, and I think that a lot of the research that has gone into it, a lot of advancements in linked data, will be very relevant for linked APIs as well. And that's why I define linked APIs as the intersection of hypermedia, big data tooling, and linked data. But at the same time, I think that a linked data falls a little bit short of what we need. If you indulge me with a metaphor, I kind of see linked data as an uncut diamond, whereas linked APIs is cut diamond when it gains all its brilliance and gains a lot of value. And the reason I say it is because it has a lot to do with the concept that we know as jobs to be done. So jobs to be done is a framework developed by a person called Clayton Christensen. Clayton Christensen is a professor of business and technology at Harvard Business School. And he's most famous for the book he wrote a while ago called Innovator's Dilemma. And then he also wrote a couple of very interesting books about innovation, including Innovator's Solution, where he defined the framework of jobs to be done. And he's also known for coining the term disruptive innovation. So he spends a lot of time looking into innovation and scale of innovation. And specifically, jobs to be done is interesting because what Clayton argues is that we a lot of time think about raw data and try to make raw data into a product. And instead, what we should be concentrating on is what are the jobs that people have to get done, right? So an example of that would be, let's say I'm buying a 4-inch drill, right? So when I'm buying a 4-inch drill, I'm not really interested in the 4-inch drill, but I'm interested in 4-inch hole, right? So I'm buying a product, but it's the job that I have to do with that product that is really the value that is delivered to me, right? So similarly, he discusses the case in the marketing, where a lot of marketing teams are concentrating on segmentation of population and demographic analysis of the population and collecting a lot of data. But at the end of the day, when I'm making a decision, it's not really based on what an average person in my segment does, but it's really driven by what I need to get done. And innovation really happens, according to Clayton, when we understand the target audiences in the sense of what are the jobs that they need to get done, and when we satisfy these jobs to get done, right? So the way it's relevant to linked APIs is that APIs are very task-oriented, especially hypermedia APIs, the read-write APIs, the action-based APIs. They're very task-oriented. Whereas linked data is more about creating links in the data itself, right? So another analogy I would bring is linked data is almost like programming before object-oriented programming, right? When we had data structures, but we didn't have encapsulated functionality, right? So it's like having a struct or enum and then moving to having a fully functional classes and objects. So something like that is happening, and linked data is part of this movement, but I think we really need to become more task-oriented. We really need to start solving the jobs that people have to get done, rather than just dumping raw data onto them and having them figure out what to do with data. Because one of the things that Clayton is arguing is that when you just integrate things without putting the context of what are the jobs to get done, you may integrate many things that are either less important or not important at all, because there are so many things to integrate, right? And you can really only optimize things when you see it through the lens of jobs to be done. So I think that's what linked APIs bring to the distributed systems, and that's the value added it provides to linked data.
Okay, I just want to mention too, we just got another question in from Niranjan, and I think it's probably the same Niranjan that joins us for most tech talks, so thanks a lot. We'll get to your question. So what can we do today to start building linked APIs? Sort of a practical question.
Sure. So the engine of linked APIs is Hypermedia, right? There's this thing that is known as Hypermedia APIs that has gotten pretty popular recently. It's based largely on Roy Fielding's original dissertation about distributed systems architecture, client-server system architecture, and specifically the Chapter 5 RESTful architectural style. But I think that Hypermedia APIs is really the implementation, right? And linked APIs is more conceptually why we use Hypermedia APIs and how we can put Hypermedia APIs to good use to solve problems like big data, data sets across organization boundaries, et cetera, et cetera. And the thing about Hypermedia is that one of the biggest things in hypermedia and what I think really helped web be what it is today is URLs, right? So URLs are a very important tool in both hypermedia as well as linked data and in general on the web. So the very first thing we can do today to start building link APIs is to give everything a URL, right? So we can, when we have a piece of data, a datum, we can make the primary key of that data be a URL, right? So most of us who have dealt with distributed systems are painfully familiar with the problems of using database-generated numeric IDs for the primary keys, right? As soon as you integrate it with something else, user ID 3 in my system, maybe somebody else with and different from user ID 3 in IBM system or Facebook system, right? So we all know these problems. And one solution to that that is widely used is GUIDs, globally unique identifiers, right? And globally unique identifiers allow you to resolve the conflicts across different systems. But where GUIDs fall short is if you give me a GUID, yes, I can be sure that it's unique, given that you use substantially strong hashing cryptography algorithm, but I don't know how to get to the entity that stands behind this GUID, right? URL is this beautiful thing that if you give me a URL, I know exactly how to dereference that URL, and I know how exactly to fetch the data behind that URL, right? So I think when we're working with the data outside, when we're working across the organizational boundaries, it's very important for any data entity to have as primary ID URLs. And it's also equally important for the referential integrity and the references between different data items to be done through URLs. So not the foreign keys of databases, not some proprietary thing that works maybe between two entities, but let's use URLs to make connections between different data items. And let's use URLs to make the primary keys of our data items so that they can be referenced across the web at the distance. And the next step is that when we implement our APIs, let's not take the shortcuts, right? So every time my user entity is referencing my, let's say, blog post, so I'm trying to say this user authored that blog post, right? Let's establish that connection through URL. And every time I need to give you a data set that includes both, let's actually do a full lookup through a URL so that in some cases, the author of that blog post and the blog post itself can both be in my database as a local, and in some cases, it can be in somebody else's database, right? So if the Twitter's index, API index, operated with URLs, then I could author a tweet and store a tweet in my database, and then they should still be able to reference it and query it.
That's
cool. Not take shortcuts.
And so who's building linked APIs today?
So that's a great question. So linked APIs is a very new concept that we're hoping will get popularized. But as we said, the engine behind linked APIs is Hypermedia APIs. And there are some really good examples. While Hypermedia APIs are pretty young, there are already some really prominent examples of Hypermedia APIs. So I'll give you some that I'm familiar with, but there are many more. So a short list would be Amazon Web Services, a new streaming API uses HAL media type, and it's a Hypermedia API. PayPal's new API is a Hypermedia API. GitHub is working on a new API that is a Hypermedia API. There's a large API called Public Media Platform that connects, like, is a good example of connecting data across organizational boundaries, because it tries to connect content across all major public media organizations in the United States. There's a Canadian company called Elastic Path, right in your backyard, Steve, and they have an API called Cortex, which is very interesting, very pure Hypermedia API. I know that Comcast uses Hypermedia APIs very extensively. There are a lot of internal APIs at Comcast that are Hypermedia APIs. And I was just actually this morning at the GSA where I was introduced to Consumer Financial Protection Bureau's new Home Mortgage Disclosure Act API, which also is based on HAL media type and is a Hypermedia API. So there are some very good examples of Hypermedia APIs that definitely have a potential of becoming full linked APIs.
Wow. So what kind of advice would you give to developers or designers of future big data linked APIs?
I would say embrace Hypermedia, embrace URLs. Those are the things that we know work at distance with the data outside, with large-scale systems, with distributed systems. Web is almost 25 years old now, so that's how long of a history we have of something working. And it works in all kinds of contexts. So that's a lesson that we need to learn and not ignore. Let's not reinvent the wheel. Let's leverage that and bring the power that we have, the rest of the web, to the APIs. Let's stop building this walled garden, siloed APIs, and build APIs the way that the rest of the web is built. Distributed, scalable, using URLs, using Hypermedia.
Right, so data sets that cross organizational boundaries, these silos.
Yep, let's break the silos. Let's
break the
connect
silos. Okay, so Hypermedia and breaking the silos. So you know what, I'm going to get to, I think now would be a good time to take Arif's question that he wrote in. It's, I know you've got it there in front of you, so I'll just read the beginning of it. I won't read all of his, it's a pretty detailed question, but basically the overall question is, what's the best practice for storing and returning linked record IDs? For example, an inventory system includes a customer reference for each inventory record. Customers are held in a separate system. So what's the best practice for storing and returning linked record IDs?
Yeah, so the quick question to that is primary ID should be a URL, and the references should be URLs, so that the data item can either be local, or if need be, it can be referenced on the web anywhere. But there was also a second part to that question, if I remember correctly, which said that sometimes the dataset providers have local IDs, which are important to them, right? And a lot of times what I have seen API teams do, you would assign a URL so that data item can be referenced across the web, but you still retain that local ID so that it can be used in some data processing as a secondary ID. A lot of times I have seen it called external ID or private ID or local ID.
Okay, great. So if let's see, Arif, if you are there, you can obviously chat in a follow-up if you want. Email if you've got anything else to follow up with the question. Hopefully that answers the question. I also just want to remind everybody that's on the stream to, if you have any questions or comments, tweet them to us with the hashtag Layer7Live, or simply just chat them right in the window there. We'll get them, and then we'll get the questions to Irakli, because now's your chance. He's here, he's live, and he's ready to answer. So I think we'll move
while
on to
people are getting warmed up, one example I wanted to give
Sure.
Steve is, unfortunately, we've all witnessed last fall a kind of largest fiasco of Healthcaregov, and there was one of the large systems that we have seen that I think really shows how the challenges of big data are changing, right? Because if you look deeply into the problems of Healthcaregov initial launch, specifically the technical challenges, right? One of the problems there was that, like, obviously there were a lot of very smart people involved in that project. So I don't believe that it was a problem of people didn't think it through or were careless about it. But it was just inherently, it was really tough problem. And one of the things that was very tough is that Healthcare.gov, while being a portal, it had to integrate with a lot of local database systems.
Sure.
Right? So what was failing a lot was these integration points, right? And that is exactly what we're talking here, that we cannot build the systems anymore as if all the data is local. We actually have to respect the fact that the data sets are distributed, the data sets are owned by their own owners, and we're just integrating. And we have to find effective and resilient ways to create an index that can actually work with all these data sets, which can be powered by different database backends, which may have different SLAs, like integrated that kind of complex systems. I think we're going to see increasing number of such problems, and I think that is exactly why really figuring out this linked APIs challenge is important. Because the next time we need to build something like healthcare.gov, we should have more theory and practice and examples of how to successfully build it technically.
Yeah, great example. So we're going to move on to Naranjan. I know you haven't had a look at this question yet, so I'll read it twice if need be. Considering the temporal value of data hugely varies as per the data source and the use case, how do we adjust resource references spanning across such heterogeneous data dynamically enough for the consumer to get back only data relevant to the ever-changing context he's in?
Okay, so I think if I understand the question correctly, there are a couple questions actually wrapped up in that question, and both of them are very important. I think one relates to the fact that URLs are not permanent. There's a famous quote. Fortunately, I'm not sure who the author of the quote is. I have seen it credited to Tim Berners-Lee, but I don't know if it's true or not, which says that any URL after sufficient time becomes a URL of a porn site, right? So
The
the
URL
point
of what?
is that
Sorry?
of a porn site.
Oh.
So domains and links and URLs become dropped, and then they can be repurposed for very different reasons. So there was actually a whole movement in the linked data community to try to keep URLs permanent, and I think it's very hard or impossible to do that. So we can. It's true that I agree that we cannot rely on URLs being permanent. URLs are a very efficient way to address data, but part of linked APIs and how it has to look at things differently than, say, linked data is to acknowledge that URLs are not forever, right? And that's also where the task-oriented nature of linked APIs and hypermedia APIs becomes so important, right? Because linked data creates these connections between data sets and kind of gives you a snapshot of what's going on in time. Whereas linked APIs are much more dynamic. Linked APIs tell you and communicate with the client their behaviors. They communicate their controls. So if the URL of some action changes, you can go to so-called home document or homepage of the Hypermedia API. You can see what the new URL of that action is. You can also sometimes establish the redirects for those URLs. So there are ways to combat the fact that URLs are not forever. So that's the first part of the question. Can you repeat the question? There's a second part of the question there.
Sure. Considering the temporal value of data hugely varies as per the data source and the use case, how do we adjust resource references spanning across such heterogeneous data dynamically enough for the consumer to get back only data relevant to the ever-changing context he or she's in?
Okay, so the other part of the question is the context. And a lot of times what I've seen, so there are many examples of that context. I don't think there's like a one-size-fits-all answer to that. But a good example that I've seen a lot of times of the context is the use case of the mobile client. right? So a lot of times we talk about APIs from the perspective of API publisher and how to optimize the job of publishing the APIs. And historically, there has been much less discussion about how to make APIs client-friendly. How do we create good user experience for API consumers? And part of that good experience is making sure that they get fast data. Things are scalable, things are lean. And a lot of times mobile developers deal with the context in which there's high latency and low bandwidth situation, right? So they really don't appreciate if we send them large payload. That would be fine if we were just doing an enterprise integration. They would like to get exactly the fields that they want, and they want to get as small of a payload to still satisfy their job as possible. So there are several approaches that I have seen to achieve such thing. One is some API providers allow you to pick and choose the fields. So you make a query, and that query determines the entities that will come out as the response to that query. But then to trim and make lean the response, you can also choose the specific fields that you're interested in, right? So for instance, if I'm querying a set of blog posts and I'm only interested in titles, I will not appreciate the full body description of the blog post because that's going to be a lot of data I may not need at that moment, right? So some APIs allow you to choose specific fields. That is one way of doing it. I think it's not always ideal because specifically indicating fields creates very tight coupling between the client and the server. And can be in the long run not so good. Can end up in breaking clients if you if you decide to add some fields or remove some fields. A more optimized solution that I have seen done is creating the buckets, right? So you create, say, a minimal response, a medium response, or a large response, right? Some people put some humor in it and use t-shirt sizes, so you have a size equal S or size equal M or size equal L. So that's when you're contextualizing the payload size of your response. And obviously you can do such things for other contexts. So you can do it for other business rules that make sense for your use case. It doesn't have to be just about the size of the payload. But bucketing is like one powerful approach that I have seen used.
Great. So I'm just going to say, I mean, we're sort of getting towards the end of the time. I'm just going to ask one more time if anybody is on the stream and they've got any final thoughts or questions to get those in. Thank Irakli if you have any final thoughts. I also just want to mention the apiacademy.co one more time. So if you're looking for design tips, we've got lessons, there's resources. It's basically a guide to API design and implementation best practices. So it's apiacademy.co. There's always new content. You can also follow the Academy on Twitter at API Academy, and obviously at Layer 7, at Layer 7. So thanks everybody who joined. I'm just going to double check that there aren't any kind of, some last questions coming in. Just Naranjan said thanks. So good that he was there to have his question answered. Thanks Irakli, I really appreciate it. And obviously the recording will be available, so check our Twitter streams. We'll post that in the next couple of hours, and you can rewatch. And also, you know, if you do have any questions that come up afterwards, you know, sometimes things need to percolate a little bit. You can always email them to us. The Academy is always there, waiting for questions and ready to answer them. So you can email them. I guess we don't need to give them an API Academy address, but you can just email questions always to techtalk@layer7.com. So thanks Irakli, thanks guys for showing up. We really appreciate it. Thanks Jose. And we are going to give away a shirt. So we'll have to decide what was the best question out of the ones we got through the email, and we'll email you back for your mailing address, and we'll send you a couple shirts, get your size. And thanks so much for everybody who participated and joined, and we'll see you sometime in May.
Thank you very much, Steve. Thank you, Jose. Thanks everybody for joining.
Thank you very much for your time.